Hi there, thanks for joining me for this bonus video of Draw, Make, and Code where we're going to make a Jacob's ladder. So let's start a new sketch. In the global space, let's declare a variable called ladder, and we're going to assign to this variable a blank array. And then inside setup, we're going to use the available window width and window height, and then let's make a loop for our sparks. 3 sparks is good, however many you like is fine. So inside that loop, we're going to push into the elements of the array a new instance of the ladder maker function, this ladder maker object. And then in Draw, let's refresh the screen each frame, and let's go through that loop again. This time we're going to execute the update function for each one of the elements in our ladder array. Next, let's make this function, the ladder maker function. So we're going to declare some variables. Since we're using noise to create the spark shape, we need an X offset and a Y offset. You could use a global variable for one of these, but I figured it's just fine. Use a function variable, it's no big deal. So just to keep things visually consistent and cognitively consistent, I use a global variable for the X offset, the Y offset. The X offset set to 0, the Y offset, so each spark has a unique shape. We're going to set that to a random value. And then we need a size to step through the increments of this wave shape. So we're going to set that to step, and then our wave has a height above and below our origin, so we're going to set that to a range that's proportional to the height of the screen. Then we need to figure out what's the left side of the spark and what's the right side of the spark, and that's going to be a proportion. And then since it's moving up the screen, we need a starting location and an ending location and a speed to move up the screen by. And then we need a variable to hold that location that we can draw the wave around. Next, let's go to update. So in update, we're basically doing 2 things. We're drawing our wires, and then we're drawing this wave. We're going to go through the loop that makes the wave. And then we continue this process every time we call update. That wave's going to be moving up the wire. And since we're moving up the canvas, we're going to be subtracting the values. So this.locate gets this.rise subtracted from it. So it will move up the screen by that increment. And then, because it's kind of a logarithmic movement, if you look at Jacob's ladder, the real thing, you'll see the spark starts out slow and moves faster as it gets along in its path. So let's account for that by incrementing the amount that's taken away as it moves up the screen. And that's what this.rise plus equals 0.25. That's going to increase the speed as it's moving upward. And then we want to make sure that we're in bounds. And if we have moved to the end, then let's just set everything back down to set the spark back down to the bottom, set the speeds back, and repeat the process. Once we've done that, then we can do the output for the lines. So we're going to isolate that in push and pop, figure out a stroke weight that looks good for a wire shape, and a color that looks good for it. And then when we draw our line, we're going to start at the base, which is the halfway point of the width, and then we're going to take a percentage of that and subtract from the halfway point, and that's going to give us this angle to our wire. The angle is important because that's what causes a change in the spark. If there was no change in the distance between the wires, the spark would just kind of stay at the bottom. So it's that distance that creates the potential for the spark to move upward. So that's an important shape that we have to capture. Also, the sparks are connected to the wire. So we can't just draw a spark of a constant length, because as it goes up, it's not going to connect to the wire. So we have to adjust the length of the wave to make sure that it's the distance between the wire as it goes up. So we're calculating a slope there. We could do the math to figure out the slope and where we need to be, but we could use map, which does the interpolation for you. It'll find out where you are on that slope by giving it the X and Y coordinates. So that's what we do to calculate where the left and right are, and you'll see me do that here. I'm putting the locate position where it's at up and down the canvas, and the range of that, which is the start and the end, and then I'm going to interpolate that to the difference in distance between the X position at the base of that line and the top position, the X position. There's that difference there. You plug that in, and the results will be where you're at on that slope. You've given it the Y position in the locate, you've given it the X position in the range there, and the results will be the hypotenuse. So you do that for the left side and the right side, and you're basically just flipping signs. Instead of subtracting from the center point, now you're adding to the center point to move the slope away. Does that make sense? So as the spark moves up the wires, it's getting kind of stretched out. So to count for that, I want the step, basically the size of that wave, I want it to get bigger. So I'm going to interpolate the amount that we should be stepping by its location up the screen as well. So it's not only interpolated to the slope of those lines, it's also interpolated to the size of the wave. Once we have all those values in place, we can run through the 2D noise wave loop. There's an example on the p5.js website page that will show you how to do a 2D noise wave, and it's basically just taking that example and putting it in here. There's some minor differences because you're using some global variables in the example, but here we're not. We're using function variables, but they're being used kind of globally. And we're still using the same local variable for Y. Plug your noise wave in. Instead of using 2D noise here, though, I use kind of a 3D noise. I use my X and Y coordinates in the noise parameter, and then for the Z parameter, I just use a coefficient of frame count, and that will give you some kind of neat movement that's over time. I think I use the Z for like a time function in this noise wave. So you're basically just doing all your noise wave stuff. You're drawing your vertex, you're advancing your X offset inside the loop, and then outside the loop you're advancing your Y offset. When your loop starts again, your X offset's going to go back to 0, so you get the same range of noise. It's congruent. And then a local variable is going to decide how thick that line is. Since the spark is narrower at the bottom, I'm presuming that the amount of flow, the electricity going through it, is going to be greater. So maybe the spark should be a little bit thicker there, and then as it gets up the wire, it gets kind of thinned out. So that's what I'm doing with the local variable thick. Then once we have that, we can decide our color, which I use a shade of blue, and put our stroke weight in there. And then if you want to, every once in a while, through kind of a coin flip, change the color to white. Maybe some molecules of the wire come off and they turn into a plasmon, and that bolt gets really bright for a split second. That's kind of what that's accounting for there. Then once we have that, we're ready to draw our end shape, so we have to put the parameters for it. We don't want it to be filled, so let's put no fill there, and I think that's it. Now let's see how I did. Get my error window open. No errors. Unbelievable. I must have had plenty of coffee when I typed this out. Anyway, that's the Jacob's Ladder program. It's a pretty interesting bit of code. Pretty simple to put together, and you can do some fun stuff with it or just watch it. It's a neat thing to just look at. And I did notice that if I follow the sparks up, it causes kind of a little bit of vertigo. So if you have any sensitivity, you might want to be careful there. But otherwise, it's a fun thing to play with, and it's super safe. I hope you've enjoyed this bonus episode from Draw, Make, and Code. And if you would, do me a favor real quick, if you have the time, drop over to the p5.js website, click on the donate page, and drop $1 in the hat there and keep things going. This is a great service. It not only helps support the platform that I use to code and make this art, but it also supports the examples and tutorials, fellowships, things that help develop libraries and add to what we're able to enjoy when we use p5.js. So if you could just drop $1 over there, it's real easy to do, only takes just a second, super secure, and it makes sure that p5.js and the Processing Foundation is around for 20 more years. So give that a try if you would, please. I sure would appreciate it. And that's what this bonus video is for, is to maybe get you to go over there and do that. So help us raise some money for the p5.js website and the Processing Foundation. And also, if you like this video, thumbs up. Subscribe if you enjoy content like this and you'd like some more. Hit the bell to be notified whenever I do upload content, and leave a comment. This helps tell the algorithm that people are interested in this, even if it's just to say hello, that the algorithm doesn't know the difference. It's just like, oh, people are typing, so let's serve them this content. So if you would do that, that would help me out tremendously. I guess that's it. Thank you so much for joining me for this bonus clip, and until next time, take care.